In this video, we are going to work a few problems involving sine and cosine just to kind of get our hands around it a little bit more. Okay, so it says if cosine of theta is 3 over 7 and theta is in the fourth quadrant, find the value of sine theta. So these typically are not those special ratios that we have come up with in the previous section. So I want to make sure we're talking about it, that sine and cosine still have those same definitions, even if they don't land on those special values. Okay, so theta is in the fourth quadrant. So I'm going to draw a triangle that's in the fourth quadrant. Right? Yep, that works for me. Okay, we'll draw this triangle. Okay, and it's a right triangle. And then I know that if cosine of theta, right, here's theta, remember cosine is x over r, or h if you want to use hypotenuse. So if cosine is x over r, then I know that the x is 3, and then I know that this is 7. All right, how we can find this third side, we'll call it b. Well, we have a right triangle, so we're going to use the Pythagorean theorem. So I got 3 squared plus b squared equals 7 squared, which is 9 plus b squared equals 49. All right, now we're going to solve for b. So I'm going to minus the 9. So I got b squared equals 40. Not 40. Did I do everything right here? Yep, okay. So that's 40. So b is equal to the square root of 40. Now, this brings us to another topic. This is a topic back in Pre-Calc 1 that you guys should have went over, but I know how life goes with that. We don't know who professor we're going to get, and maybe you don't remember it. That's okay. So this square root of 40, we like to knock these down to numbers that come out of my square roots pretty. So what I can do here is I'm just looking for perfect squares, like the 49 is a perfect square, right? Square root of 49 is 7. 81 is a perfect square. 9, right? If I take the square root, 4 is a perfect square because 2 is the square root of that. Anything that's a pretty square root. So what I'm going to do with this 40 is change it to 4 times 10. And this is the same thing as 4 square root of 4 times the square root of 10. I can split radicals when it's a multiplication sign, but I cannot split it when it's a plus sign. Okay? If you want to see, if you don't believe me, let's take 16 plus 9, all right? If I split it, it's in question. Square root of 16 plus the square root of 9, well, that's 4 plus 3, which is 7, right? If I follow that route. But if I go this different way, this is an accurate way, 16 plus 9 is 25, which is 5. 7, 5 are not equal. This is where you can't do that. So if it's a plus sign or a minus sign, you can't split your radical. But if it's a multiplication sign or a division sign, you can split your radical up. Okay. So this becomes, after I split it up like that, the reason we picked 4 is because now I can take the square root of 4 and get it to 2 square roots of 10. This is simplifying radicals. You may need to review simplifying radicals. If you need to, go find some videos. I think I have some videos. You just got to ask me in the email. You can send it. They're videos from like 5-6 years ago, but the process hasn't changed at all. Okay, so this b side then is 2 radical 10. So if I'm doing cosine, remember cosine, we already have cosine. Cosine is 3 over 7. That was x over r. And then remember sine is y over r. So this is going to be 2 square roots of 10 over 7. Just what goes there. 2 square roots of 10 over 7. So the sines and cosines, like we got an exact answer, but we're just using the definitions x over r, y over r, right? It's not going to always be those nice pretty values that the last videos have been over. Those are only for those special angles. But remember, I can find a sine or a cosine of any angle I want because it's based on a revolution. Okay, let's look at problem 2. Given that, there's some in the homework of this, given that the point -3, -5 is on the terminal side of an angle theta, evaluate the sine and cosine of that angle. So -3, -5, that is in quadrant 3. So I guess I can make it to scale a little bit. Let me put it right here. The x is smaller than the y. And this is my angle, but we don't want to use that angle when we're talking about. We would rather use its reference angle, which is just going to be right there. And I can draw this right triangle straight up here. I don't think that's pretty straight. Right, there's my triangle. It's pretty straight enough. Okay, and we know that this side is a -3 and this side is a -5. And they want us to find sine and cosine. So remember, sine is y over r, and cosine is x over r. Well, we don't have r in this case, but how we can find r is just use the Pythagorean theorem again. So we get negative 3 squared, we'll call this c, I guess, plus negative 5 squared equals c squared, and that's 9 plus 25 equals c squared. Well, that's going to be a 34 equals c squared, which means c is the square root of 34. And then I want to take this moment to point out that r, and this is maybe you go up and put it in your last notes, r is always positive. R is always greater than 0. So and the reason I'm saying that is because we should have had a plus or minus here, right? When I take the square root of an equation on both sides, I get a plus or minus. But in this case, since it's the r, it's the same. So this c, I'm going to go ahead and replace with a positive square root of 34. R's are always positive. And then I just got to find sine. Okay, so sine is y over r. So it's going to be negative 5 over the square root of 34, right? And then cosine is going to be your x over r. So that's a negative 3 over the square root of 34. We're done. They just wanted the ratios given that. So if they give you a point, put the point in the quadrant, right, wherever it's at, and draw a triangle and label it. Remember, these are x's and y's. So if you have a question, or if you're wondering, or you're questioning, well, why didn't I just say sine is y and cosine is x in this case? Well, the reason being is they did not give us that it was a unit circle. It has to be on the unit circle, or if they just said something like this isn't the problem, but if they said something like this is assuming r is 1. Okay? But in this case, when we draw triangles, like in the wild, whatever that means, right, that I have in these two problems, the r is going to change. It's going to be different. Remember, we can have r be whatever we wanted. We just let r equal 1 because that made it very convenient when finding these ratios given just an angle. All right, we have one more. I like these. I enjoy them. I don't know why. It's like, no, I'm not doing them at home for fun or anything, but let's take a look. Okay, they want us to just figure out, given these positive negative rules, what quadrant does our angle land in? Okay, so we can talk about cosine and sine. We're dealing with unit circles. Cosine is x, sine is y, like normal, didn't change. So this says, okay, cosine is greater than 0. Well, if cosine is x, that means my quadrant I'm in, the x's have to be greater than 0. So I'm going to put like x's where they could be. Here's greater than 0. Here's greater than 0. Remember, cosine is x. That's where x is positive. This also says sine. So this meant x is greater than 0. This meant y is greater than 0. Well, y is greater than 0. Let's put it in red, actually. Here and here. Well, my answer is going to be where they're both possible. So this is quadrant 1. Right? Q1. Okay, now all you have to do is figure out which quadrant. So this is x is less than 0. So x being less than 0, that means x is negative. So I'm going to put them there and there. Could be in one of those. And then with my red one, sine is y, right? So y is less than 0. That happens here and here. So that means my answer is in quadrant 3. Right? I'm going to do the cosines for the last two with blue and then switch to red. Cosine is less than 0. That means x is less than 0. So that means those two quadrants are possible. And then sine has to be greater than 0. That's in red, right? That's up here. So that means my answer is in quadrant 2. Okay, we got one last one. X is greater than 0 because cosine is greater than 0. So that puts me in quadrant 1 and 4 because x is positive there. And then my other one, sine, that's y is less than 0. So that is, if y is less than 0, it's here and here, which means my answer is in quadrant 4. I like these problems. Typically, I like to put them on test because they're really great. It gives me a really eye-opening experience. If you know the definition, straightforward for sines and cosines, knowing they're related, cosines related to x and sines related to y, this is a great question for that.